Hey guys, welcome to Python for Beginners tutorial. This is day one of Python tutorial for beginners. You can start learning Python programming from scratch. And don't forget to like, share, and subscribe, and write comments in the comment section of this tutorial as well. So we're going to explore an introduction to Python programming, comments, functions, and variables, and strings in Python programming. So this is the basic programming tutorial for beginners. If you are absolute beginner, you can start learning and you can be a Python developer. Okay, what's Python? Python is a programming language like other programming languages such as C++, Java, C Sharp, and other C programming languages. Like other programming languages, gives us a way to communicate our ideas with a computer. So in the case of a computer programming language, our ideas are commands that help us to communicate with a computer. So as a computer programmer, so we communicate with a computer through commands. So the computer could understand our commands, our ideas through commands through the computer program. That is the language that the computer and the computer programmer communicate with each other. So Python is one of the computer language that help us to communicate with our computers through commands, and the commands which contains our ideas to communicate with a computer. Python is one of an interpreted object-oriented high-level programming language with dynamic semantics. Python is also a powerful dynamic type programming language. So we can classify computer programming into dynamic and static type programming language. Most of the static type programming languages are called compiled languages. So Python is not a compiled language. It is interpreted language that interprets each of the commands line by line, then running or compiling all source codes at a time. So Python is a high-level built-in data structures combined with dynamic typing and dynamic binding that make it very attractive for rapid application development, as well as for use as a scripting or glue language to connect existing components together. The other thing of Python that is simple, easy to learn, syntax emphasizes readability, and therefore reduces the cost of program maintenance when we compare with other programming, especially compiled programming languages. Because it is a dynamic programming language, it is easy to learn syntaxes, and it is easy to read. So it reduces cost of program maintenance. That is the best thing. That's why we choose Python programming for artificial intelligence and machine learning. It also supports a huge developer community, packages, and modules, which encourages program modularity and code reuse. So it supports huge resources on the internet. The Python interpreter and the extensive standard library are available in source or binary form without charge of all major platforms and can be freely distributed. So you can use the packages or any other major platforms. So the first thing, how to start Python program is every programming language has its own source extension to identify the type of the program. So the first, for example, let's create day1.py. Py is the source extension for Python program. So the interpreter could understand that this is Python. So everything written inside this files could be interpreted by the Python interpreter, and we see the output is, so we organize our ideas in commands inside this file, and the computer could understand your commands, and it's allow us to communicate with the computer through our commands, which organized inside the Python file. Okay. So the first thing inside this, so once you create your file, like .py file. So you can give any file name, but most of the time it is recommended that you write a descriptive file name that identifies the purpose of the script written inside that file. Okay. The first thing we are going to learn in this tutorial is comments. So comments, how can we define comments inside this? For example, we basically use hash symbol. So this hash symbol is used for commenting lines of commands inside the Python file. So whatever written inside this comment or with a hashtag, that is a comment. So the interpreter couldn't run that. It can be ignored by the interpreter, the Python interpreter. So it will not display on the output device. So ironically, the first thing we are going to do is show how to tell a computer to ignore a part of a program. So the computer interpreter could understand that this is a comment. For example, if you're something, this is a comment, so that the interpreter ignores this line because this is a comment. So the text written in a program but not run by the computer is called a comment. Python interprets anything after a hashtag, because that is a comment and ignored by the computer interpreter. So comments can provide a context for why something is written the way it is. So if you write after something commands inside that file, so you can easily understand that why you write this line of code. So that comment could tell you or could tell something that this line of code is for this purpose. Okay, let's comment something. This code will calculate the sum of 2 plus 2. So without understanding that line of code, you can simply read these comments and you can understand that the following code is just calculate the sum of 2 and 2. So this tells us and we can easily understand. That's why comment is. And comment help other people reading the code and understand it faster. So as a professional developer or programmer, comment is very essential. So you should write comments for each line of code. Why you write that line of code? So other people or reviewer can understand that this line of code is written for this purpose easily. Ignore a line of code and see how a program will run without this. So this returns the sum of two numbers, for example. Let's say there is another way of writing comment. So we can use, for example, 3 single quotes. So inside this single quote, especially if you want to write a multi-line comment, this is return the sum of 9 plus 3. Okay. This is multi-line comment. This is a single line comment. So if you want to write a single line comment, you can use hashtag before the text. And if you want to write multi-line comment, you can use single triple quotes, or you can write double triple quotes. Double triple quotes, that is a comment. So you can use either double triple quotes or single triple quote to write multi-line comments. Okay, especially if you are if you wanna write the purpose of the function, you can use this. This is a type of docstring. So this is all about comments, and the next is about function. What is the first function that you are going to learn as a beginner is print function. So this print function now going to do is teach your computer to communicate. So the gift of speech is valuable. A computer can answer many questions we have about how, why, or what it is doing. Those are the very essential questions that the computer going to do. In Python, the print function is used to tell a computer to talk. So the message to be printed should be surrounded by quotes inside this. For example, if you want to print, you can put any message inside this. Hello, world. So every message should be surrounded by the quotation, either single quote or double quote. So here, print function just tells her to talk. Okay. Now, once save this file and run this code. To run this code, you can type Python 3 on terminal, and you can call the file name after that Python command. For example, day1.py. Yeah, the output is just printed. So this function tells to the computer what to do. So the computer can do that. It prints this as an output. So this print function tells to the computer, please print this output on the screen. So it could be visible to the programmer or the user. So the user can understand this output, but the user couldn't understand what is written inside this file. Okay. So this is the way how you could communicate with the computer. So you just give your commands to the computer, and the computer can understand your idea. So that command is written in the file, and the interpreter will interpret your commands, and then it prints out the output on the screen, and you could understand that output as a beginner. So the message to be printed should be surrounded by a quotation, either single quote or double quotes. For in this case, I just use single quote. Python could understand either single quote or double quotes. So you can change it to double quotes. And you can run this code and it prints the same output. But if you begin with single quotes, it should be ended by double single quote, not different or other quotes like double quotes. So once begin with single quotes, it should be ended with single quote as well. For example, in this case, it just highlights an error because it is a string literal and terminated because it is begin with single quote, it is not ended with the same quote. So if it is begin with double quotes, it should be terminated with double quotes. That is the case that as a beginner, you should understand. And let me run this, for example. So this is syntax error. The syntax error says that unterminated string literal. So this should be terminated with the same symbols of quotation. So it does return that output as well. Okay, we could also, for example, if you wanna print the sum of two numbers, for example, 9 plus 3, you don't need to surround by double quotes, but you can use, for example, 3 plus 9. It just prints that, so the computer could understand that this is addition because these are integers, not strings. So in between two integers, there is operation. That operation is called addition operation. So it can perform this is addition, and it prints out the sum of 3 and 9. That is the all. Okay. So this print statement or function is very essential. So it's prints the specified message to the screen or other standard output devices. So the message can be a string or any other object, either integer or Boolean or any other objects. So the object will be converted into a string before written to the screen, before printed out on the screen, okay? So this is a basic to Python programming. And the next is strings. Computer programmers refer to blocks of text as strings. So every block of statements which is surrounded by quotation is a strings. For example, this is strings, but this could be a comment because it is surrounded by three double quotes. This is basically doc string type. And for example, as you can hello, or for example, 9 plus 3. If any messages which is surrounded by quotation is a string, when you print this, for example, it just prints 9 plus 3, not the result of the sum of 9 and 3, because it is surrounded by quotation. So everything which is surrounded by quotation is a string. So the computer could understand that this is a string and it prints as it is. So in Python, a string is either surrounded by double quotation or single quotation, as I have said earlier. So it may be surrounded by single quotes or double quotes, whatever it is called strings. Yeah, the same. So it doesn't matter which kind you use. Python supports double quote or single quotation to surround strings, okay? But you couldn't use start with single quotes and terminate by double quotes. That is error, syntax error. So it is unterminated syntax error. So you should use the same ending, starting and ending quotation to surround strings. Okay. The other important thing is variables and naming. Variables very essential in computer programming. So every computer programming language offers a method of storing data for reuse. So we could store any type of data in a computer and we can reuse that data anytime we want to use, okay? So if there is a creating, we wanna present a date, we need to reuse, or a user ID, we need to remember, we can create a variable which can store a value. So variables are containers that can store data values in a computer memory. So that container is like a trash can. For example, a trash can is a container that stores as trash, okay? The same is true in computer memory. You can store any type of data. For example, string data, integer data, Boolean data, or any objects, and you can reuse that data by calling then the container, the variable, okay? That's why we call it reuse that variables. In Python, we assign variables by using the equal sign. For let's assume x and assign. This is assignment operator. So we assign values to that variable. For example, 3. So 3 is a value and x is a variable. And this is an assignment operator that could assign the value 3 to the variable x in computer. So in computer memory, this is a container that could store this value. If you want to use this or if you want to get the values from computer memory, once it is stored, you can refer the name of the variable. Okay. So for example, if you want to get the values stored in x variable, I just call the x variable, and when you run this code, you can see that 3 is stored in that x variable, okay? Unlike other computer programming languages, Python has no command for declaring a variable. So we can simply, there is no any keywords or commands to declare variables in Python, but in other programming language like C++ and Java, we first specify the type of the variable which kind of values you want to store in computer memory. But here, any type of values could be stored in computer memory without specifying the type of that value. Okay. So a variable is created the moment you first assign a value to it. Once you assign value to that variable, so the variable could create in computer memory, and that variable could store the value. Okay. So we don't use any. That's why we call Python is a dynamic type of programming language, because it's just dynamically allocate memory spaces when you assign value to that variable. For example, if you change the value of this, for example, any string, automatically store that string instead of integer. Okay, so it just identifies the type of the that variable after storing that data in computer memory with the variable name. So the memory space can be allocated after the value is stored in computer memory during the assignment of that memory, not before assigning the value of the variable. So for example, let's assume we have message underscore string, and this is a variable name, and this could store any either string or integer or string. For example, hello there. This is a string, so this variable could store any type of data in computer memory. For example, if you want to print this, you can just call the variable name and reuse. This is called what? Reusing that variable anytime we want. Okay, now I can run this code and print out the result. Hello there. Hello there is already stored in computer memory, so this message underscore string variable, and I can reuse this variable anytime in my computer program, and I can see what is stored in that variable. Okay. In this example, we store the message hello there in a variable called message underscore string. So variable do not need to be declared with any particular type in Python. That's why we call it a dynamic type of programming language, and you can't even change the type after they have been set. Here, I can even change, for example, for. Initially, I was defined a variable which stores string, but I just modified that value and I stored for. So if I print message twice, and it could print the first and the second, but the variable is still the same, but it just stores different values. So that's because it could store any type of values, it doesn't matter. So that the space in the memory can be determined based on the values we store in that variable. All right. So in C++, we can create variable. For example, in C++, we first determine the type of the variable x, and we always store the same type. We couldn't store a string, for example, hello there, because we already determine the type of the variable that this variable could store integer type only. That is called static type programming language. It is good actually for efficiency. That's why now in 2023, there is a new programming language that's called Mojo programming language that supports C++ and Python features as well. Okay, all right. So string variables can be declared either by using single or double quotes, as I have said. So you can store any string values, either single quote or double quotes in string variable. For example, let's say a variable first name, which is a civil. and first name. So when I call, for example, okay, here in the first, I just define the variable first name and the values is Asiba in single quote. And the second first name, the values is Asiba in double quote. So in two variables, then basically in natural, it is the same, but they are different. Here, I used underscore to separate two words as a single variable. Here, I used camel case, the camel case without a space, without underscore. I just use capital letter in the first word of the second word. So when I print this, it prints out the first one only. The second is not printed out. So variables, a variable can have a short name like x, for example, 12, or y, whatever, a, b, it doesn't matter, or a more descriptive name. But it is strongly recommended that we use a descriptive name like first name. For example, this can describe that this variable stores the first name of any person, okay? And the second is also the same. So when you are defining a variable, you can use descriptive name instead of x. X doesn't describe any values. It's just x. X stores whether integer, string, or whatever. That's what kind of data that x variable is storing. We couldn't understand the type of the data. But when you are using descriptive name, when defining variable, it is good to describe what is the value that the variable is storing in memory. Okay, so for example, if you wanna, let's say this is 30, let's stores age. Let's assume this stores age of a student, okay? And another variable, age 30, age of student. So which name could describe the data stored in that variable? X stores the age of a student, okay? Age variable also stores the age of student. So age variable is a descriptive name. So it just describes that this value is the age of a student, okay? We can understand that. So you always consider that when you define a variable, you could use descriptive name rather than using any variable. Okay, that's the good and recommended way. Rules for Python variables declaration. Variable name must start with a letter. So always start with a letter like this. Not a number. For example, if you start with a number, it's just errors because a statement must be separated by new lines or semicolons because this is not a variable name, a wrong variable name. So it always begins with a letter and followed by any number, for example, 1, whatever, x1, say, doesn't matter. Variables can have spaces. For example, when you remove this space and an underscore, it's errors because first is not defined. You see, this is error and you couldn't use spaces between two consecutive words as a single variable. So either using underscore or like camel case without space. Even you don't use hyphen. Hyphen is not allowed in variable declaration, okay? Only like underscore is allowed. You can begin with underscore, but you can't begin with numbers. Underscore is possible to begin variable name. And can't begin with numbers, but they can have numbers after the first letter. So variable name can only contain alphanumeric characters and underscores. Alpha. For example, you can't use like other special characters. Like it's not possible to use variables begin with any special characters except underscore. Okay. All right. Variable names are case sensitive. So as I have said, for example, first underscore name and first name, just two variables are different. They are storing different values. Okay. So for example, age 14. This age in small letter and this age in begin with capital letter they are different. They are storing different variables. So they are, when you are calling, for example, age in small letter, it's just printed the first values only because they are case sensitive. Okay. It's not coincidence. We call this creatures variables. If the context of a program changes, we can update a variable but perform the same logical process on it. So in this example, we create a variable message string, first name, last name, age, or whatever, and we assign different values to each of the variables. So after we print each of the variables, it just prints out the values of the variables stored in that variable, not the variable name as it is. Because this is called reusing the variable, and because we store data in computer memory through that container, and we are always calling the name of the container that's storing the values, and it's just printed out the values stored in that container instead of the variable name as a text or string. So that's the thing. So you should understand, you should keep in mind. So it is just assume a trash can that stores a trashes. So when you are keeping trash inside that trash can, that's a container. It stores any kind of trashes. So when you are, the same is true in variables, it just stores any kind of data. And when you are calling the container to print the values stored in that container, and it's just show us what is stored in that container, okay? Which is a valid variable name. So for example, let me give you an assignment. For example, the first one, 2 underscore x 2, and second question, first name Steve, and third question, age is 30, and fourth question, x underscore 23, which is 23, and fifth question, which is underscore age, that is 30, and the other is sixth question, first space name. Okay, one more question, last hyphen name. Okay, and heights is last name. So I just want to ask you a question. Which of the following variables are valid. So you can just write in the comment the numbers. Sorry, this is which number. For example, if you choose 2, 4, 5, you can write separating by comma in the comment section of this. Sorry, and I wanna just now if you get understand about today's tutorial. So if you like this tutorial, don't forget to like, share, and subscribe. Write comments below. Thanks for watching. Hello guys, welcome back to day 12 Python for beginners tutorial. On this tutorial, you will learn how to determine object types in Python and also how to convert object types. So Python is one of the most powerful object-oriented programming language. There are many different types of objects in Python. So the most common object types in Python are strings, integers, and floats. Those are the most common types of objects in Python. So we can store different types of data in our computer through variables. So anytime you write texts, words, or characters, which is surrounded by quotations, let's say greeting. So hi there. So this is the message which is surrounded by single quote, and this message is a text, a sequence of characters. So the sequence of characters is called a string. So the type of this object is a string type. So when you print out this, you will see that hi there. So the most common numbers on the other hand is, for example, 0, -1, 1, 100, etc. So those are the most common integer numbers. So integer numbers, any numbers, including 0 or negative numbers or positive numbers. So that represents an integer type. And the floating type represents like fractional numbers. For example, the float numbers 3.14, which is a floating number that represents real numbers. And for example, -4 to 0. So this is also a floating point or a floating number that stores or represents the real number. So those are the most common types of data or objects in Python program. So what this can be represented by string in Python or any messages which can be surrounded by quotation is strings, or a sequence of characters are also strings. For example, let's say x is 1, 1. So this is what an integer type. So 11 or 1, 1 is an integer, and it prints out 1, 1. But this is not an integer. For example, if you put this in quotation, so this is not integer right now because everything surrounded by quotation is called strings or string object in Python. And for example, if you store variables like 3.14, and this could be a floating point because this represents a real number in Python. There is a fractional number after decimal, so that is the floating type, object type. So types of, for example, here this is string, okay? So you can get Python to tell you that the type of an expression by using the built-in type function. For example, how to determine the type of object in Python. So to determine the type of objects in Python, we can use type function from Python's built-in function. So this type function can determine the type of data that is stored in variables. For example, if I want to determine this X type, let's print and determine the type. We pass that variable inside the type function X, and it's just determine that this type is a string. str represents a string in Python. If I change X to Y, for example, Y is a floating point because this is a decimal numbers, and this represents a real number. And also, for example, if I determine that greeting, I call greeting variables, and what type of data are stored in this greeting variable, that is a string as well. Let's store, for example, okay, any variable xyz, and let's store true. So what type of data this xyz variable stores? Type of this object. Okay, so this type of object is Boolean because Boolean has two values, either true or false. Let's determine this variables. That is a bool. Bool means Boolean value. So this is a Boolean type object. And we can also, for example, let's remove the quotation from the X variable values, and let's call that X into this type function. And let's see that this type of data is integer. So this is the way how we can determine the type of the data. Using the Python's built-in function, which is called type function. All right. The next is about how to cast or convert from one object type to a different object type. For example, I could have integer. So first, I determine the type of X, that is integer. And if I wanna convert this type into, for example, floating point, I can cast the type of the object into this X variable. Let's say I just cast float instead of type. So that value could be converted into decimal number, but initially it was integer. For example, let me, after cast, or let me cast X float X, okay? And let me print out after converted the object integer to float, and let me print that. So this is now 11.0. Initially was integer, and let me determine the type of this X after converted into floating point X. So that is float. So this is the way how you can convert from one type to another type. For example, if I wanna convert an integer into a string, so I can just cast str. Okay, that is string. This is a built-in function that used to cast from the current object into another object type. So you can just use the name of that type as a function and pass the variable that you want to cast or convert into another object. Okay, so if you want to convert, for example, xyz is right now true, and if you want to convert to for example, a string, I just pass x, y, z. Now it is a string. And if I want to convert it to int, for example, int, so it's just converted into int. And when you print out, for example, this x, you could see 1 because it is true. True represents 1 in integer. So if you change this to false, for example, that could be 0 because 0 is integer. But now I converted from Boolean to integer using int function. Because these are the way how you can convert from one type to another type, that is object casting, or converting any types of object into another object using this mechanism. So converting from strings to integers or floating point to integers, but you be careful that, for example, you couldn't convert greeting, for example, the sequence of characters into any other types. For example, let me convert greeting. So that is error, invalid literal, because these are the sequence of characters. You always convert digits, which was in string type, but you couldn't convert any sequence of characters into any other objects because that has character. So it's not possible to convert or cast into another object type. But you can convert any other digits which are in, for example, in quotation, this is string, but you can convert to integer x, for example. That's possible. So that's are some of the common way how you can convert numbers to strings to numbers, floating point to integers into floating point as well. And also you can convert Boolean data type into integer and integer into Boolean. For example, if let's say we have 0 is integer right now, but you can convert to Boolean x, y, z. Okay, that's Boolean. It is converted to Boolean, but initially was integer. All right. So this is another example. So we can cast Boolean into integer or integer to Boolean. So here I want to give you an exercise to do by yourself. For example, the first exercise is, what is the data type of the result? 6 divided by 2. And the second question is, what is the type of the result of 6 divided by 2? So write your answer in the comment section of this tutorial, and I will give you a response for your answer, and we will discuss more if you couldn't understand about this questions. And also you can join us on Telegram and ask your question in the Telegram groups. And don't forget to like, share, and subscribe, and write comments below. Thanks for watching today. Hey guys, welcome back to day 3 of Python for Beginners tutorial. In this tutorial, you will learn the operators and expressions in Python. I will cover some of the most common operators and how to perform expressions, and also what are operands in this tutorial. So this tutorial is practical oriented. So you will learn by practicing a lot of exercises. So don't forget to like, share, and subscribe. Write comments below. Let's go. In Python, operators are special symbols that design it that some sort of computation should be performed. The values that an operator acts on are called operands. Operators are the constructors which can manipulate the value of operands. And expressions in Python can include operations among compatible types. For example, integer and float. For example, the basic arithmetic operations like adding multiple numbers. Let's say x is 3 and y is 4, then result x plus y. So in this arithmetic expression, So for x and y are variables which stores 3 and 4. And so the values of the variables x and y are called operands, and the symbol, the plus symbol, is called operator to perform an arithmetic expression. So this is called expressions. There are different types of operators in Python. One of the operators are arithmetic operators, comparison or relational operators, assignment operators, and logical operators, membership operators, identity operators, and bitwise operators. So we will see each of the operators practically. One of the arithmetic operators is addition, adds values on either side of the operator. So let's assume 3 plus 4 is 7. So the operator is addition. So it just adds on either of the side of the operator. Okay, so the result would be 7. And subtraction is another operators in Python. So it's just subtract, but this is different from addition. In subtraction, we just subtract the right hand operand from the left hand operand. So the operand is x, which stores or holds the value, integer or float, and the right hand is also operand. So this is operator. So we just subtract the right hand operand from the left hand operand, and we get, for example, the left hand operand, the values of left hand operand is 3. We subtract 4 from 3 and we get -1. So this is what's called subtraction. Multiplication multiplies values on either side of the operator. So just for example, let's multiply. In multiplication in Python, we use asterisk or star symbol from keyboard. It is computer programming we use as a multiplication symbol. So we multiply in either of the sides of the operand and we get the result. So x multiplied by y is 3 by 4 is 12. We get the result is 12. The other is division. So in division, we use forward slash to divide left hand operand by the right hand operand. So we get the result is, for example, 3 divided by 4 is 0.75. So this is division. We get floating. The result of the division is float. It's not integer. So we will use double up forward slash to get integer result while dividing the operands. Okay, so this double forward slash is different from single forward slash in division. When you are dividing left operand by right operand in using a single forward slash, we get float result. But when you are using double forward slash while dividing numbers or operands, so we get integer result. That's the two different types of division. The other is modulus. In modulus, we use percent symbol from keyboard and we get the remainder. So we divide the left hand operand by the right hand operand and we get the remainder. For example, 3 divided by 4 is not divisible. So we get the remainder is 3. Okay. So this is what's called modulus. So always we get the remainder while dividing operands. Okay. The other arithmetic operator is power or exponent. Exponent, for example, exponent this by y, for example, this is exponent double when you are using double asterisk. So that is called exponent, where just performing x power to y. X power to y is 3, the power of 4 is 81. Okay, that is exponent. So it's performance exponential or power calculation on operands. So we have discussed about the float divisions. Float division is that integer division, y is double forward slash. So the quotient when x is divided by y rounded to the next smallest whole number, the next smallest whole number. So 3 divided by 4 is the next whole number is that 0. So that is integer division. For example, let's change 9 by 2. So what is the result of 9 by 2 in floor division or integer division? So that we get 4 because that is the next smallest whole number is 4. Okay. But when you are using division, that is 4.5. That is a real number representation. We get the real number. So 9 divided by 2 is 4.5. That is a real number. So we are dividing 9 by 2 and we get the real number of that division. But when you are floor division, that is different from division. So that is integer division. We always just get or round it to the next smallest whole numbers. Okay, that are the most common arithmetic operators. So you can perform by practicing to master arithmetic operators. So actually, if you understand what are the arithmetic operators, so you always use the operator or in your project. So it doesn't matter. Okay, let's go. The next is comparison operator. So the comparison operators that is used to compare for two values, basically. So the comparison operator, let's say x is equal to 4 and y is 5. Let's say that equal, for example, if you want to compare to x and y, if they are equal or not, so you can use, let's say, a result. So the result always be Boolean, either true or false. For example, x is equal to y. So let's print out the result. So what is the result? That's false because 4 is not equal to 5. This is a comparison operator that compares x and y, and we get either true or false based on that conditional statement. So this is always evaluated the conditional expression. So this conditional expression results either true or false. Okay, we always get true or false. That is conditional expression. So the condition becomes true if the values of the two operands are equal. In this case, for example, 4 and 5 are not equal. So we get false as a result. Otherwise, if they are equal, for example, let's say this is 4 and we get true because 4 is equal to 4. This is one of the operator, which is called a comparison operator. The other is not equal. Not equal is, for example, let's change this to 5 and we use this symbol and assignment as a comparison. X is not equal y. Yeah, if it is true, it always evaluated the conditional expression. So the conditional expression resulted that either true or false. So if x is not equal to true y, so that is true. 4 is not equal to 5. So we get true. If we change this to 4, for example, that is false because x is not equal to, x is equal to, basically x is equal to 4, but according to the comparison, x is not equal to y means they are equal, so we get false result. Okay, the other is greater than or less than. The condition becomes true if the values of two operands are not equal, false otherwise, using this one. But if you use, for example, greater than, let's say, for example, let me change this. 4 is not greater than 5, so that is false. Or if I apply equal, greater than or equal, that is false. For example, if I change this to 6, 6 is greater than 5. Okay, true. But if I change this to 5, for example, 5 is not greater than 5, basically, they are equal. So this expression evaluates either is the left operand greater than or equal. So the left operand is not greater than the right operand, but they are equal. So we get true. So it evaluates two conditional statements. If the left operand is not greater than the right operand, we get false. Because here, for example, for x greater than or equal to y, x is first evaluated the greater, so it is less than, so it just gets false result. But if you change, for example, to less than symbol, this is either less than or equal to. For example, 4 is less than 5, that's true. Or let's put 5, that is equal to 5 is equal to 5, that's true. Because this expression evaluates less than or equal. So this is a comparison operator. So we can perform greater than or less than or greater than or equal to or less than or equal to based on the operands, left or right operands. All right, so those are the basic comparison operators. Okay, let's go on. The other is assignment operator. Assignment operator, we already know assignment operator that assigns value to a variable. So this assignment, a single equal sign is assignment operator. So when you read this value, for example, x is equal 5, it is absolute x. Don't read like that, x equal to 5. If you want to read x equal to 5 like this, but this is called assignment operator to read that 5 is assigned to the variable x, not x is equal to 5. Okay, so this is called assignment operator. So variable holds the assigned value. Okay, we can perform assignment and addition at the same time. For example, let's increment. That is increment. So if I wanna, for example, x plus 2. The initial value of x is 5, but here I just modified the value of x by adding 2 in the initial x value. So this is the way how you can perform. But you can also perform, for example, let's comment this, and plus or equal 2. So this is the same with this one. So we can perform addition and assignment at the same time. So which means x, we add 2 to the x variable and assign to the x again. So the value of x is the sum of x with any other variable, for example, y. For example, let's say y. Okay. Yes. Which means this is y. X plus y is assigned to x. So we get, for example, x is 10. Initially, it is 5, and I added 5 to the x variable, and we get the sum of x and y. So this is called assignment and addition at the same time. You can also perform assignment and subtraction. For example, 5 minus 5 is 0. And multiplication, you can perform multiplication and assignment. For example, 5 times 5 is 25. You can perform division as well. Division. So this is the shortest method to perform and arithmetic operators. Okay. Modulus, exponent, whatever you can perform. So you can use like this. All right. The other is logical operators. Logical operators are not and or operators. So the not operators, true if x is false, false if x is true. Logical reverses the sense of x. Let's say x is true. Let's say this is evaluate is the Boolean value. Okay. So let's print not x, for example. Not x means the value of x is initially assigned true, but when I apply logical operators, not x means that is the opposite of x. X initially true, but I reverse it to false. Okay, not x means the result is false. For example, if I change true to false for the value of x, now the reverse of false is true. So this is what's called logical operator. Okay. What about or? Let's say we have another y. Okay. And to perform this, x or y. So what's the result? X or in or, either one of the two operands is true, the result is true. So in this case, x is false, but y is true. So in all logical operators, so we get true. But if both is false, so we get false because x and y, x or y are false. And we also use AND operator. So the logical operator using AND. So to get true result in the end, both should be true. Otherwise, we get false. For example, in the case both are false and we get false. For example, let me change to true, one of the operand, and we get false. In AND operator or logical operator, so we always compute that if both operands are true, otherwise false. For example, if I change false true and we get true. So these are very essential to evaluate logical operators. For example, if let's say I have false, if not x and y. I first just reverse it. What is the reverse of x? X is initially false and I reverse it to true. And I connect x and y with AND logical operator and both are true. So the result will be true. That's what's logical operators. All right. If you have any question, you can ask me in the comment section of this tutorial, and let's continue about membership operators. Very essential, especially these membership operators are essential. Python membership operators test for membership in a sequence such as strings, lists, or tuples. There are two membership operators in Python. Yeah, one is in and the other is not in. That are the most essential operators that evaluates to true if it finds a variable in the specified sequence and false otherwise. Let's say x is hello Python and y is, for example, t. Okay, and if I wanna just find the membership of y in x, I can use, for example, y is in x. If y is a membership of x in the sequence of characters, so it returns true, otherwise false. But in this case, y is p is a member of a sequence of these characters. Okay, that's why it returns true. For example, if I use not in means not a member of x. Y is not a member of x, which is false because in this case it is a member of y. I mean x. So let me change it to x, for example. X is not a member of y because x is not found in the sequence of characters in X variable, so it returns true. But if you change this, Y is, which means X character is a member of sequence of characters in X variable, which is false because X is not found in the sequence of X variables. So these are very essential. So you have to just evaluate this to true if it finds a variable in the specified sequence, otherwise false. And not in means that evaluates to true if does not find a variable in the specified sequence, and otherwise it's false. The other is identity operators. Okay. In the identity operators, let's say all right, identity operators compare the memory locations of two objects. This is very essential to compare the memory location of two objects. There are two identity operators explained in this example. For example, is and is not. Membership operator and identity operators are very useful in the futures tutorial we will discuss. So the is evaluated to true if, for example, let's say X is 10 and Y is 10.0. So the is operator, let's say raise X is Y. Is, in this case, is the memory location of I is the same with the memory location of Y. If it is true, it just returns true, otherwise false. So in this case, is evaluated to true if the variables on either side of the operator point to the same object and false otherwise. And so in this case, for example, let's print the identity, the ID. We use ID function to get the identity or the memory location of the variable X, and let's print the ID of Y. Okay. As you can see, these are the memory location of the variable X and the memory location of the variable Y. So let's print the result. That's false because as you can see the addresses of each variable, so they are not the same. They are different. So it evaluates to false. But if you use, for example, if it's not, means they are not the same. So it's just returns true because the second variable, Y variable stores floating point. So the address of the first variable is not the same. For example, if you remove this, it's just return the same address because equal, they have equal value and the memory space also the same in computer memory. So that is what identity operators. So you can just evaluate the identity of operands in Python program. So in this tutorial, we have discussed the different operators and how to perform expressions in Pythons using different operators, including arithmetic operator, comparison operator, logical operators, membership operators, and identity operators, and so on. So I hope you enjoyed this video tutorial. Don't forget to like, share, and subscribe. Write comments below. See you in the next video tutorial. Hello everyone, welcome back to day 4 of Python programming tutorial for beginners. Today, you're going to learn about errors and exception handling in Python. In this tutorial, I will explore the types of errors and how to handle the errors occurred in your computer program. So as a computer programmer, everyone prone to making mistakes. So everyone also typically in charge of creating computer programs. To composite programming language attempt to understand and explain mistakes made in their computer programs. For many types of mistakes, Python will tell you that you have made a mistake by giving you an error message. It is also important to read error messages carefully, to read, understand where you made a mistake and how you may go about correcting it. For example, if you spell a print statement, a print function is a built-in function that used to print the statements or any messages include these quotations. So if you probably miss that or mistype it, the P with F, so this is not defined early. So you can't use this function because the interpreter couldn't understand that this is not recognized by Python interpreter. So it's tell you that you made a mistake in your program and you try to understand your error and make it correct. So you have to just correct by changing F with P, and now it prints out the message. Python also refers to these mistakes as errors. So we'll point to the location where an error occurred. When programs throw errors that we didn't expect to encounter, we call those errors bugs. Yeah, probably errors are bugs. So programmers call the process of updating the program so that it no longer produces unexpected errors. That is called debugging. So process of fixing errors is called debugging, but the error occurred is the bug. So you have to try to understand the errors and you have to go through the errors and fix that error. That is so-called debugging that error. So that process is called debugging. The error message tells you that where the error occurred. For example, if you make an error here, so it tells that and also tells you what type of errors occurred in your computer program as well. Okay, so here it just highlights you that here is an error, and you can try to figure out the errors and correct it. Some more useful in large notebooks, shells, or scripts. So Python attempted to run the function fprint, but could not determine what fprint is since it is not a built-in function and it has not been previously defined by user. So we will learn how to define a function that's called user-defined function. This function was not defined yet. So or it is not a built-in function. That's why it just highlights an error. There are basically two common errors that we encounter while writing Python. So one is syntax error. So the syntax error means there is something wrong with the way your program is written. That is called syntax. For example, punctuation that doesn't belong, a command where it is not expected, or a missing parenthesis can all triggers a syntax error. For example, if you miss something here, so there is a missing, so there is opening parenthesis, but that parenthesis is not correctly closed. So that is called syntax error. So this expected, this was never closed. So this is so-called syntax error, and there is any other, for example, if you miss, for example, quotation, it just indicates that there is an error where the error is occurred. It just shows you that in your lines of code, okay, unterminated string literal. So you can just correct that error. The other is name error. For example, this if you miss that the name of the function is incorrectly defined here or incorrectly used, so that is the name error because that name is not defined yet, or that name is not a built-in name in Python. So so-called name error. So these two types of errors are most commonly occurred errors in Python programs. So you can understand what type of errors occurred in your program. So the name error occurs when the Python interpreter sees a word does not recognize code that contains something that looks like a variable but was not never defined will throw a name error. For example, if you are trying to use a variable never defined before, for example, print x. X variable was not defined, but you are using that variable in this print statement. So that is so-called name error. So you can define that variable before using, okay? Before using x instead. Now the error is fixed. It just prints the values of that variable because the variable is already defined. All right. So far, so good. So you'll notice that if you make a different types of mistakes by forgetting to close a string, you will obtain a different errors. That is so-called syntax error. Does Python know about your error before it runs your code? Python is what is called an interpreted programming language. I have already discussed in an introduction to Python programming in the day one tutorial. So it is compiled languages examine your entire program at compile time, but Python is just examine your program at runtime, not compile time. So errors can be also determined or handled at runtime because it is interpreted programming language and are able to warn you about a whole class of errors prior to execution. In contrast, as Python interprets your script line by line as it executes it. So Python will stop executing the entire program when it encounters an error, unless the error is expected and handled by the programmer. For example, let's try to see an example. Print. This will be printed. Okay. Look at on the screen. Print. This will cause an error. Print x and print this will not be printed. Okay, look, the first line, because Python interpreter just interprets your code line by line, starts from the first line and goes through each line of the code and prints if it is free from any errors. Let's begin with the first line. The first line is just printed out because this is free from any errors. The second is also printed out, but the third line is not printed yet because there is error that is called name error. X is not defined error. So after this error, no program or code is executed because the error stops here. So the executing this program will be stopped here because the errors occur because interpreter just interprets the code line by line. And if there is error occurred somewhere in your code, it's just stops executing after that error. Okay, that's why the first two lines are executed, but after the third line, it just stops executing the program. So this is what's called interpreting language. That's why Python do not know the errors before executing the program. But using compile programming language like C++, before executing the code, it's just compiles the whole program and it just determines the errors where it is occurred in your code and it tells you to fix the errors, okay, before executing that program. But this is completely different from compiled language. That's why we call it interpreted programming language. I hope you learned about errors and other valuable skills that will continue to serve us we develop our program skills. So you can figure out the errors you encounter in Python program and understand and explain the types of errors in your Python program. But when you are writing any program, so you can handle errors using exception handling. Exception handling is a mechanism that allows programmers to handle errors and other exceptional events that occur during the execution of a program. For example, let's say if there is an error here and you can use try, you can put the codes inside the try and you can handle exception. For example, the except is name error, okay? Then print this error and print that error, okay? Look, the program is smoothly executed without any errors. Look at the first line is executed, the second line is executed, but the third line is not executed, but it just prints out name X is not defined message. Okay, so this is the way how you can handle to smoothly execute your program without any errors displayed in your screen, okay, or console, okay. For example, if you avoid this try, so you see that here is the error message, okay. So you can avoid these error messages using exception handling, using try except method. So if there is no error, it just prints out this statement. Otherwise, it prints out the errors handled. So the first two lines are just executed without any errors, but when it's the errors occurred at the third line, it goes to the exception. So you can exceptionally write messages even here. Name error. Okay, just there is some name error. So then you can fix that error and you can, for example, let's say X, Y, and Y is 0. Zero division, so this is a zero division error. So you can replace this zero division error. Yeah, number doesn't divisible by 0. So there are different errors, but the most common errors are syntax error and name error. So you can also handle, you can easily identify the type of errors inside in the screen. For example, here, just show you that zero division error. So you can replace the zero division error in this name error in the exception. And you can handle that error. All right, because number doesn't divide by 0. For example, if you replace this one, it just correctly print it out. So this is called exception handling. By using exception handling, programmers can prevent errors from crashing their programs and can provide users with more informative feedback about what went wrong in their program. The concept is present in many computer programming languages, so including Python, Java, C++, and many others. But the difference is the syntax, how to use the exception handling. So you can use try. There is a code block in the try that is colon. And in Python, there is indentation and a code block. So every code block has indentation. So you should keep that you make it indented to identify that this code is or this statement is under this code block. Okay. For example, if you and indented this part is just errors, because this statement should be under this try block, okay? Try block. And then the except block is also there. So you always use a block statement, and every block statement should be indented, okay? Keep your mind. That is the most important thing in Python. Indentation is very, very essential. But other programming language consider that. You just use indentation for code formatting in other programming language, but Python is mandatory to keep every block of statements indented, okay? Basically, there are three basic concepts in exception handling. So the exception, generally, an exception is an object that represents an error. Exception means the errors, okay? Or other exceptional events. Exceptions are thrown by the program when an error occurs. So exception is thrown by the program when an exception or an error occurs. For example, here, 2 is not divisible by 0, so the error is occurred. So the exception is just occurs here. So that is the exception. So the exception is 0 division error. So that is the exception. So you have to handle that exception. And the try block is basically a block of code that is monitored for exceptions. So if an exception is thrown while the code in a try block is being executed, the exception is handled by the appropriate catch block. Okay, that is except. And the catch block is except. So the catch block is a block of code that is used to handle a specific type of exceptions, a specific type of errors. And catch blocks are associated with try blocks. So in Python, exceptions are errors that occur during the execution of a program. So they disrupt the normal flow of the program and can be handled using try and except method. Okay. So in this case, for example, this is an error is occurred in this case. So the exception just handles that errors and it prints the error message instead of that the statements inside the try block. So the basic exception handling with try except, this is example, and in this example, the try block contains the code that could potentially throw an exception. For example, 2 divisible by 0 is not possible, so that is exceptionally throw an error. Okay, so this the catch block is used to handle the zero division error, or any syntax error, or any name error, whatever the error is. For example, if you use a print hi, so you just replace this name error. Okay, so you can change this name error. So this is name error. The error is just occurred in the try block. So if the error is occurred in the try block, it goes to the exception, because the exception catches the errors occurred and it prints what error occurred in the try block. Okay, that is just stops the normal flow of the program when the errors occurred. All right, so we can handle that error using the try except block in Python. So the benefits of exception handling, it is very essential for improving program readability. It gives more informative error messages. That's good. You can customize the error messages and it gives you error messages. It avoids any error messages displayed on the console. Also, it helps us to improve code readability. So those are exception handling in Python. I hope you enjoyed the tutorial. Don't forget to like, share, and subscribe, write comments. Hey guys, welcome back to day 5 of Python for Beginners tutorial. And this day 5 tutorial, you're going to learn about string manipulations. After completing these topics, you will be able to work with the strings, perform string operations on string, and manipulate strings using indexing and escape sequences. Strings in Python, like many other programming languages, are arrays of bytes representing Unicode characters. However, Python does not have a character data type. A single character is simply a string with a length of 1. For example, let's say X with a single character A. So this is a single character. So this is called a string in Python because in Python, there is no data type that represents a single character. So everything which is enclosed in quotation is strings in Python. So whether it has one character or single character or a sequence of characters, it represents a strings. Okay. This is a string with sequence of characters. So we can also use single quotes or double quotes in this string because Python supports both single quotes and double quotes. So you can use either single quote or double quote to surround strings while defining or declaring string data. A string can be a combination of spaces and digits. For example, here there are a space. So a single space represents as a single character in Python in strings. For example, let's say X, and let's say we have 2, 3, 4, 5, 6. So we have digits with the spaces. So every digit in this quotations are strings. And the spaces also represent a single character in a string, okay? So in this case, when you count the number of or elements or the lengths in this string are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, around 11, because we have 5 spaces in each digits. So we can determine the length with len function. So let's say we have 11 characters in this x variable because in between every digits we have spaces. Every single space represents a single character in length. So we can determine the length of the strings using len function, and we can pass the variables which contains the strings into that len function. So the len function is used to determine the length of the string. All right. Okay. So, for example, in the first, we can determine how many number of characters we could have in the string Michael Jackson string. So we have 15. So we can count 1, 2, 3, 4, 5, 6, 7. We have 1 spaces, 8, 9, 10, 11, 12, 13, 14, 15. So every space represents a single character in a string. So for example, let's assume removing the characters and you can just determine the length. So we have 0 length, but when you provide a space in the quotation, you could have 1 length, 1 space. And if you add more space, we could have 2 characters. If you add more space, we could have 3 characters. So 1 space represents a single character in a strings. Okay. All right. Let's go on. And special characters in string also represents a string because a string can also be a combination of special characters. For example, special characters like So all those are characters because string is a combination of special characters, digits, and in general, it's also a combination of alphanumeric characters. Okay, so uh, so we can determine that how many characters we have in this special variable. So we can have 10 because everything in the quotation represents a string in Python. Whether a single character, whether it is a single space or any space or tabs, whatever it is enclosed in the quotation, either single quote or double quote, it is called strings. We can also use multi-line strings in Python if this is a single line string representation or definition, single line. Just as we discussed in the first day tutorials, we could have multi-line comments and single line comments. Okay. In a string, we could also have multi-line like this. So you can open with 3 quotes and enclose with 3 quotes or triple quotes. So for example, so we can use either single, triple quote or double triple quote to define multi-line strings in Python. We can determine, for example, the length of how many characters we have in this multi-line strings. That is n. We have 213 characters, okay, including space or whatever in these characters. For example, because we have one line after quote, so I just remove that and the number of characters reduced. All right. And even though here, that's so this is what's called a multi-line string. So you can assign a multi-line string to a variable by using 3 quotes, either 3 single quotes or 3 double quotes. Okay. The other is indexing. Indexing is important in Python. It's helpful to think of a string as an ordered sequence. Each element in the sequence can be accessed using an index represented by the array of numbers. Let's assume we have Michael Jackson sequence of characters in a string variable, and we can represent this in a memory, and we can access a character from a sequence of characters by using indexes. For example, all right, so every character represents or stored in memory with indexes. So we can access each character from that memory using indexes. The first character in computer is at index 0. That is index 0. Index 1 is the second character. Index 2 is the third. So in this case, the first index, index I, starts from 0 and it ended with n minus 1. N represents the total number of characters in the sequence. So in this case, we have 14 characters because you can count from 0 index to 30 index. So it is 14. So the last index is found at index 13 because n is total number of characters is 14 and we subtract 1 from the total number of characters and we get the last index, the last character index in the sequence. That is n found at index 13 and m found at index 0. The first index can be, for example, a string at index 0. So a string at index 0 can be m character. So we can access the characters from a sequence by referring the index or the position of the characters in the memory. Okay, so the characters represented as indexes starting from 0 up to n-1. N represents the total number of characters in the sequence. So this is the way how you can represent characters in memory. Okay, so we can access every characters by referring the index or the position of the character where that character is found. For example, if you want to access the character at position 5, you see, at position 5 is E. So you can just use print string at position 5. So you get E character is found at position 5. Okay. So because indexing starts at 0, it means that the first index is on the index 0. And for example, if you want to get the 40th index, you can index at 40th. Index at 40th is n. So we have 50th element, I think. Yeah, 50th. Yeah, we have 50 elements in this case. So we can also access, for example, element at position 6. At position 6, for example, is L. Position 7, for example, at position 7 is a space. So you can't see that as a character. The space represents a single character. All right. So moreover, we can access the 30th event. For example, the 30th event is O. In this case, that is O. So the last, and the other is negative indexing. There is also a way how you can access elements from negative indexing, from the last element to the first element in the sequence. Okay, the last element is -1. Always the last element is a -1. So for example, in this case, let me access the last element that is -1. That is n, the last element. If you want to access element at position index 2, that is on, because it just counts from the last and goes down to the first. Okay. And for example, fifths. Negative indexing fifths is this one. But if the positive indexing at fifths is 0, 1, 2, let's say print at fifths is E from positive indexing, but the negative indexing at fifth is C. So you can get or access elements or characters from a sequence of characters using negative indexing as well as positive indexing. Okay. Negative index can help us to count the elements from the end of the string. Yeah. The last element or character represents -1, and the first character always represents 0. So the last element given by the index -1, and you can do that. All right. For example, let's compare using comparison operator. Let's say print a string at position 0 is equal to string at position 15. Do you think that a string at position 0 is equal to string at position -15? Character is found at 0 index, and according to this, so when you are starting from the last index with negative indexing, so you can found that the first index is at -50th index. that's equal, so it is true. Okay, that's possible. And for example, 50s, no 50s, 40s, and -1. That's also true. 40s, we have 15 elements, and so we always subtract 1 in the positive indexing to get the last index. And in the negative indexing, you can access the last element using -1 index. So this is equal. So this is comparison. You can apply comparison to compare strings in the indexing. All right. So we have also seen about how to find the number of characters in a string using len function. And the other is slicing. Slicing is very important. You can obtain multiple characters from a string. So we can obtain multiple characters from a string using slicing. You can obtain the 0 to 5th, for example, in the string. You can obtain string 0 to 5th. You can use colon. So this is called starting. For example, you can obtain from 0 to 5th means this is end of the index, and this one is the start. So it always starts from 0 index. It includes the first index. It ends with the 5th index, but not including the 5th element. Okay, end with 5th index, but not including this element or character at index 5th. That is the end, but it's just obtain 0 index 1, 2, 3, 4. These characters can be obtained. The 5th one is not included in the slicing. So in this case, so that is maker. Okay, this can be obtained, and the 5th index character could not be included in this slicing, but it includes the starting index, not including the ending index of slicing strings or characters. We can obtain, for example, from string from A's character to 12. So it just starts from A's. It is from J and up to K. The 12th character is S, but not including, because this is the ending of the slicing. The other is stride. Stride is also a slicing. So you can also input a stride value as follows, with 2 indicating that we are selecting, for example, string 2. This is if you are using double colon. If it is a single colon, it separates the starting and ending indexes during slicing. Here is also a stride. It is double. The first one is just colon that's used to separate the starting and ending, and the second one is a stride. So get every second element. In this case, starting from, if you didn't specify the index of the starting, so you are starting, by default, you are starting from the 0 index. And this means just obtaining every second characters from a string. So it starts from M, the first character, and what is the second characters for M? it just jump this one, and the second character for M is C. Obtain M and C. What is the second character for C? That is A. And the second character for A is L, and so on. So it's just obtaining all the characters for every second element for that character. For example, if you start from, if you specify the starting index 6, and if you stride every second element starting from the 6th index, the 6th index is L. So it starts from the L and it obtaining every second element. For example, if there is a space, one character, and the second character for L is J, it just obtain J, and the second character for J is C, just obtain C, and the second character for C is S, it just obtains C S, and the second character for S is N. So this is called stride. So you can obtain any characters you want from a sequence of characters or strings in general. So you can also incorporate slicing with the stride. In this case, you select the first 5 elements and then use stride, for example. And stride with 2 is from M up to the 0 up to 4 is M, I, C. Yes. So we stride every second element. So it starts from 0, that is M. The second element in this case is C. So we just specified the ended with the fourth element. So the stride is ended here, and we obtain that M and C. M and C. But if you remove this one, you can obtain MICH without stride. Okay. The other important concept in string manipulation is concatenation. Concatenating strings is very essential, so we can concatenate or combine strings by using the addition symbols. And the result is a new string that is a combination of both. Let's say, right, if I want to combine, for example, grading, let's say, reading, hi, then I want to combine hi, my name, my first name, that is called the name of the variable that stores my first name, and then last name, and let's print that reading. So we can obtain hi, my name, but you can provide spaces here. You can concatenate spaces in between, for example, plus a space. That's essential to separate. Yeah, correct. Hi, this one. So you can use plus symbol to concatenate strings together, one more strings together, and obtain the required information. So to replicate values of a string, we simply multiply the string by the number of times we would like to replicate it. In this case, the number is, for example, I wanna replicate print 3 times hello. You see? Hello, hello, hello. It just replicated 3 times. You see, this is called a replication. So you can replicate any strings uh, like this. Asterisk is one of the multiplications. You can multiply the strings using this way. For example, if I want to replicate this 4 times, it just replicate 4 times. Okay. So you can create a new string by setting it to the original variable, concatenate it with a new string. The result is a new string that changes from the previous to the new one. So that's the good thing. The other important concept in this case is cap sequences. Cap sequences, that is a backslash, represents the beginning of escape sequences. Escape sequences represent strings that may be difficult to input. For example, backslash represents a new line. The output is given by a new line after the backslash n. So it encountered that, for example, print Michael Jackson backslash n is the best. So after backslash n, it just starts with new line. So this is called escape sequences. Or for example, backslash t. This is if you wanna just provide more spaces, tabs to the lines, you can use backslash t. So this is the way how you can use escape sequences in your string. Similarly, backslash t represents a tab, so you can provide more spaces. If you wanna place a backslash in your string, use a double backslash, for example. If you wanna use backslash you can use backslash, double backslash. So backslash is included in your sentence. We can also use R before the string to display the backslash. For example, R without double backslash. You can use R before the beginning of the string. Okay, that's the thing. And backslash is used to write single quotes. For example, remove. Yeah, you can use backslash this, or you can remove this. And if you wanna just put quotation using these escape sequences. So there are many escape sequences you can practice and learn more about string manipulation. The other is string formatting. So string formatting is also important. So as we learned it in the Python variables topics, we cannot combine strings and numbers like this. Like, for example, age is 30 and the text contains, my name is Asiber and I am class age. See? So in a string, you cannot, this is type error, can only concatenate strings, not integer, because age variable contains integer and you can't concatenate the strings and integers together. So in this case, we can use, you can use string formatting mechanism. For example, print F. F is the most commonly used string formatting and easy. And you can call parentheses, and inside parentheses, just call the variable which contains the string, and another variable age. You see, text, the first, it just replies the name, and after that, I call the age, which is an integer. So this F string formatting. So this is the way. There is also another way. You can use uh, format method. So the format method is basically, for example, here, format age text. You see, age is concatenated. So you can use format method and pass the variable as an argument to this format method, automatically assign that variable value to this curly braces. So that is the way. So the two string formatting methods are very essential, either F string or format methods. There are also other string formatting, but those are powerful and commonly used string formatting in Python. So the format method takes unlimited number of arguments. You can pass unlimited number of arguments and are placed into the respective placeholders. This is the placeholder that holds the argument value in this format method. So the other is string operations. There are many string operations in Python. String operations or methods. Actually, you can practice. There are a lot of string manipulation methods to manipulate the strings. So you can learn more about string manipulations online, and I will show you some of the commonly used string methods in this tutorial. Let's try to use the method upper. Upper is one of the string manipulation method, and the other is for load for title. So the this method converts lowercase characters to uppercase characters. For example, let's say I have a string A. The string contains, let's print, for example, A. So here is the six, six stereo alpha, and after converted into, let me convert it into uppercase, and I call the variable that stores the string and use dot upper method, and when I print the B, yeah, all characters in the string are converted into uppercase. So this is the method how you can convert small letters to capital letters using upper method. You can just use dot upper method. The same is true for low. You can convert, for example, it's just all upper cases are converted into lowercase. And the other is, for example, D, that is used to make a title. So the title converts the first character of each word to uppercase, for example. Now let me convert C to title, and let me print that. Yeah, every first character of each word is in the sentence are converted into upper or uppercase. Okay, this is what's called title. The other is capitalize. Capitalize means just in the beginning of the sentence, every the first character should be capitalized. So you can use, for example, E, then we convert E, capitalize. Yeah, here I have one sentence, and the first character in the sentence is capitalized. The other is a strip. Strip method this removes any white spaces from the beginning or the end of the characters. For example, if I provide a space here in the beginning of the sentence, so just for example, a dot strip. Now it just removes that. It just removes the spaces. For example, initially there is a space as you can see in the output, okay, in the beginning of the sentence. But after strip, the white space from the beginning is removed. For example, if I add white space at the end, it also removes the white spaces from the A as well as the beginning of the string. That is called a strip. So this is very important, especially data analysis is also replace method. Replace method replaces a segment of the string. For example, a substring with a new string. If we have a substring and we replace the substring with a new string, so we input the part of the string we would like to change. Let's say A is the best, okay? And I would like to change A dot replace. This replace method takes two arguments. The first, and I mean the substring, which contains the substring and the new string. So the first argument is the substring, for example, and is so I wanna change. This is old string that's gonna be changed by the new string in this replace method. The new string, for example, is Janet. Sorry, Janet. If I print B, Asiba Janet is the best. That's initially defined Asiba Tanaga is the best. This is the way how you can replace strings. These are the most commonly string manipulation methods, such as upper, low, title, replace, capitalize, and strip. But in a strip, there is also left strip, right strip. There is also count that used to count the characters, how many number of occurrences that a single character in a string is occurred. You can count. You can use find method that used to find some characters from a string. So you can read and practice more. And I hope you enjoyed in this video tutorial. Don't forget to like, share, and subscribe. Also, write comments below. Thanks for watching. Hey guys, welcome back to day 6 of Python for Beginners tutorial. In this tutorial, you will learn about functions in Python. After completing this topic, you will be able to understand and work with functions, work with different built-in functions, define the difference between user-defined function and built-in functions. Many programs in Python react to user input. Functions allow us to define the task we would like the computer to carry out based on user input. A simple function in Python may look like this in maths. For example, f of x equals 3x plus 2. So this function takes a user input x. So every user may input different input value. For example, if user 1 may input 6 and replace 3 times 6 plus 2 is 20. And user 2 may input 2, 3 times 2 plus 2 is 8. and user 3 may input 3. 3 times 3 plus 2 is 11. So many users may input many input data and may get different outputs. So that's so-called a function. So a function in Python is a block of code which only runs when it is called. When the function is called, it runs the output and we get the value as a result. You can pass data known as parameter. This x is called a parameter, and we pass data through these parameters as an argument to that function when the function is called. A function can also return data as a result. So it returns when that function called, for example, when the function is called, it returns 20 as a result. A function is a block of organized reusable code that is used to perform a single related action. So function is basically used to organize our code, and we can reuse that function anytime. For example, if we have a student database, so a student database, it is very hard to write all programs that can do a student's grade, student's registration, student's exam, and so on in one program. But if we divide that program into many functions and we organize each of the functions based on that tasks, so that is easy to maintain and understand also. So that's why function is reusable. As already we know, Python gives us built-in functions like print. Print function is a built-in function that tells to the interpreter or the computer to print out the strings enclosed that function, hello. And we have seen about some of the function, for example, length, that determines the length of the sequences, for example, hello. That is 5, for example. We have also seen that let's define a variable x. X is, for example, 5. Let's determine the type of this variable x. So this is type function is also a built-in type function that used to determine the type of the object, that is integer in this case. And we also use another ID built-in function that used to identify the memory location of the variable x, for example, this one. So this is some of the built-in functions in Python. There are a lot of built-in functions in Python. You can learn and you can master the Python's built-in function after all. Basically, there are two types of functions in Python, user-defined functions and built-in functions. So we have seen some of the built-in functions, and you will also learn more built-in functions. But in this tutorial, we will focus on user-defined functions. For example, we have a function here, f of x 3x plus 2, and we define a function to solve this problem. So to do this, we use a keyword that is called def keyword, and we define, for example, do math followed by a function name. So you can use different function name, doesn't matter. But when you are defining a function like variables, it is recommended that you use descriptive function name. For example, do math. So you can do any math. And this function takes the variable or parameter x. This is x, and we just use x. And there is a colon after the function name that is used to indicate a block of code inside this function. So when you are enter, automatically indented the block of statements inside this function. So this is called block of statements. So every function has a block of statements. So every block of statements can be break up using colon. Okay. So whenever you define a function, so you must define the block of statement in that function that's going to return as a result. So this function can do, so it can do 3x plus 2. The x is the parameter that the function takes, and we accept the user input through this parameter when you are calling that function. Okay, let's do. So it's stored as a result variable that is 3 times x plus 2. This is a formula or a computation or a problem that's going to solve using this function. Okay, and there is also a return statement that returns the output as a result. So return, we call that a statement. So instead of race, it's going to return the results. So the results, this formula compute and store the result into the variable race, and the return statement going to return the value of race as a result. For example, here, if we input 6 as input parameter, and it's going to compute by replacing 6 by x, and it's going to return 20 as a result when you are calling this function. So this is called the end of a statement. End of statement. So this is very useful. For example, if you call this function call, to call this function, and you can use the function name, and this function has a parameter, and you can pass argument to this function. So the function takes input. So that is the user input. So the user can input, for example, 6 to the function as an argument, and it's going to automatically assign to the parameter x in function definition, and it's going to replace the x with 6 and computes 3 times 6 is 18 plus 2 is 20. So the return statement going to return 20 as a result. So this is called function definition. And this is called function call. So when you are calling that function, it can perform the tasks which is defined inside that function and returns the result of that function. So here I just print R1 and just calls the function and assign or pass the user input 6 as an argument to this function, and automatically assign that user input to the parameter x, and it replaces the value of x to the x in the function body and computes the mathematical computation and returns the result of that function, and we get 20. So for example, if another user 2 may input and call that function and inputs, for example, 2, and print that function result R2, and we get different, that is 8. Okay, that is 8. And user 3 may also call that function and input different data, R3, do math. So once you define that function, you can call many times as necessary. And 3, print R3, that is 11. And instead of just doing manually, you can solve many problems by defining user-defined function. So this is called user-defined function. When you are defining a user-defined function, you can use a keyword, def keyword, followed by the function name. And the function may take parameter, or sometimes it may not take a parameter, okay? And the function may solve some problems, and it may also return the result using return statement. So when you are defining a function, you use a keyword def and followed by the function name, and the function may take parameter to input the user's data, and it may return that values as a result, and so on. So indentation is very essential in Python functions that indicate the block of statements. Okay, if you make it indented, it is error. So every block of statement like colon, that is called a block of statements. So that should be indented inside that. So easy to organize your code, read your code. But in other programming language, indentation is not necessary, but it is just to make your program readable. So function call is just to call that function and pass data to that function. Once the function is defined, many user may call that function and pass different data to that function as an argument and automatically assigned to the parameter in the function definition. Okay, this is so-called a function, and you can, for example, let's do if you wanna compute square. If you wanna compute squares of a number, you can use it look like this. But it is easy to define a function that compute the squares of a number, and you can call that functions and pass different data into that function. That is the easy way to perform squares. Okay, let's do it. Define a function, square. By the way, in one Python file, you can define many functions, doesn't matter. So whenever you call that function, that's just pass data to that function and returns, for example, x, and it's going to return x squared, okay? X squared. And you can call that function, call the function, and pass data to that function, for example, print 5. Okay, so we get, when you are calling in the first one, and the input is 1, 1 square is 1, and 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. So this is easy way. So you can define functions once and you can call that function. So you can reuse that function many times as necessary. And you can also define a function to solve Q. Q, okay, X, and it returns X cube. So you can replace this cube. Okay. Yeah. 1 cube is 1. 2 to the power of 3 is 8. 3 to the power of 3 is 27. 4 to the power of 3 is 64. 5 to the power of 3 is 125. This is what's called solving cube. And so those are some of the examples how you can define user-defined functions in Python and solve many problems by organizing your code and reuse that function as necessary. This is what's called function definition. I hope you enjoyed this video tutorial, and we will see another topics in the next day. Don't forget to like, share, and subscribe. Write comments below. Thanks for watching. Hello guys, welcome back to day 7 of Python for Beginners tutorial. And this tutorial, you will learn about function scopes. By the end of this tutorial, you will be able to understand the difference between local and global variables. Function scope is the code block or body of any function in Python. This Python scope contains the names that you define inside the function. Whether you define variables or functions inside that function is called local scope of a function. So function provides a nested namespace, sometimes called a scope. So a variable is only available from inside the function is called the scope of that function. Let's define a function square and create a local variable inside this function, which is x, that stores a value of 4. the function is going to return the square of the variable x. So this variable x is the local scope to the function square. It can be accessible inside this function only, local variable. It will not be accessible outside of that region. Okay. So then we call that function square, and we get the result, the square of that number. So if you want to access this, for example, x outside of the region, because x is local to the function, it's gonna be accessible inside that function already. But if you access that local variable outside of that function, it is an error because name x is not defined. So a variable which is created inside a function belongs to the local scope of that function and can only be used inside that function. The other important thing is you can define a function inside the function. So that is called nested function. So Python function allows to define a nested function that is local to the outer function. First of all, let's print this, the square of x squared, and let's print square of x is square. All right, and let's define another function after the statement of the outer function is printed out. So that function we define inside this function is local to the outer function. So that is called inner function. So the inner function couldn't accessible outside of the outer function because that is local to the outer function. For example, q. But we could use the variable x as a global variable to the function q because this variable x is defined outside of the function q. All right, now to access the statement that's inside this q function, we can call this function inside the outer function q. So the square of a number 4 is printed out. Then after printing out this statement, it's going to print the statement is defined in the inner function. So this inner function is local function to the outer function. The outer function is a square. So this q function can only be used inside the square function. And the variable x is global to q function, but it is local to the square function. So you can access the variable x inside the square function. So this x variable is global to the q function, but it is local to the square function. Still, you couldn't access the variable x outside of the square function because that is defined inside the square function. All right, to make it global, we can define this x variable outside of the function. So it's gonna be accessible global variable. So you can access the variable x anywhere in the program, either inside the function or outside of the function. For example, here, x is accessible outside of the function. You can also access that x variable inside any one of the function, because this x variable is a global variable, and whatever you define outside of the function, you can use that variable throughout the program. Okay, that is called global variable. The other important thing that you should understand is you can make the local variable as a global variable. For example, here I define a local variable, but this local variable is not accessible outside of the function. If you want to access the local variable outside of the function, you can define the global variable using global keyword. So in this case, you can make the local variable global using global keyword inside of the function, and this variable can be accessible outside of that function as a global variable. Okay, so when you are defining a local variable as a global, you first define the variable using global keyword and then assign the value to that variable. You cannot assign value at the same time when you define a global variable in the local scope. So this is called define global variable in the local scope. Okay, so you make like this. So these are the difference between local and global variables. So whatever defined inside the function is accessible inside that function. But if you define variables outside of the function, it's gonna be accessible outside of the function as well as inside of the function or the rest of the program. Okay. For example, let's define a function that multiplication and takes a parameter x, and this parameter x is incremented by 1, and the function gonna return y multiplied by 2. Then we define a variable y and assign value to the variable y and call the function melt and pass the argument to the function melt. So in this case, this argument is passed to this x variable, and the x is incremented by 1. So initially it is 4, and when it is incremented by 1, it is 5. It is 5. But the return statement is not using the variable x or the parameter x to return the values. And instead, it is using the global variable. Whatever defined outside of the function is global, and it's going to be accessible anywhere in the program, either inside the function or outside of the function. It doesn't matter. So in this case, the result is 8. So if you are using x, it's going to be 10 because the value of x is incremented by 1 and multiplied by 2, it's going to be 10. So this is what called global and local variables. I hope you understand the difference between local and global variables in Python's function. Don't forget to like, share, and subscribe. Write comments below. Thanks for watching. Hello, guys. Welcome back to day 8 of Python for Beginners tutorial. In this tutorial, you will learn about parameters versus arguments. By the end of this tutorial, you will be able to understand the difference between parameters versus arguments. And also you learn the return and pass statements in Python's function. To let a function return a value, use a return statement. So for example, let's define a function that has 2 parameters, x and y, and it's gonna return x plus y. So this return statement leads to the function that return a value. So when you are calling this function, results are passing arguments to the function, then This function returns the sum of x and y and store the result to the variable race. Then when you are printing race, you can see the result of the function as an output. But print and return statements has a key differences. The return statement just return the values of the function, and when you are calling the function, it's gonna just store that result of the return statement in your variables look like this, and when you are printing that result, you can see the output on the output device. A return doesn't display the output, but it's just return the values of the function as a result. So print and return statement has differences. So you could understand the difference between return and print statements. The other important concept that you should know is the pass statement. Function definition cannot be empty, but if you, for some reason, have a function definition with no content, for example, here, the function is defined, but there is no block of statements inside this function. So this function expected to define block of statements inside this function. So there it generate an error because of every function should have a block of statements, but you miss defining the block of statements in that function definition. To avoid that error, you can use pass statements. So this pass statement is just to avoid getting an error in the function definition while you are defining an empty function. That's it. Okay. The other most important thing that you should know is parameter versus arguments. The terms parameter and argument can be used for the same thing, information that are passed into the function. But they have some key differences. A parameter is a variable listed inside the parentheses in the function definition. For example, here we have two parameters, x and y, and the parameter, if you have more than one parameter, you should separate by comma. So here, x and y are parameters. So parameters always defined in the function definition inside the parentheses of the function. And the arguments are different from parameters. So an argument is the value that is sent to the function when the function is called. Here, the function is called and I pass two arguments into this function, and those arguments are automatically assigned to the parameters listed inside the function definition. So this is called a positional argument. So A, 3, and 4 are positional arguments. So the first number is assigned to the first parameter in the function definition. The second argument is assigned to the second parameter in the function definition. So that is called the positional argument. Each position of the arguments are assigned to each position of the parameters inside the function. So positional arguments are mandatory. So if you missing, for example, one positional argument in this case, it just generates an error. So in this case, 2 plus 3 is 5. If you, for example, passing one position argument, but you have two parameters in the function definition, so it just throws an error. The error said the add function missing one required position argument, that is y. The first argument is automatically assigned to the first parameter, that is called position argument, and there is no second argument in the function call, but there is one positional parameter in the function definition. So you should specify equal number of positional arguments to the number of parameters in the function definition. All right. The other most important thing is that the number of arguments must be equal to the number of parameters. So here I have two parameters, so I must pass two position arguments to each of the parameters. For example, if you pass more than two parameter arguments to the function, but you have two parameters only, so the error says add text to position arguments, but three were given. So you should avoid the third position arguments to avoid this error. The other most important thing is default arguments. In some cases, you may specify default arguments. For example, y is 4. So this is called a default argument. The default argument allows you to specify default values. So you can provide a default value to an argument by using the assignment operator. For example, this 4 is assigned to the parameter y. So you don't need to specify argument in this case because we have a default argument here. So the default argument is evaluated during the function definition, not in the function call, because it is initially assigned the default value to the parameter x. So it's gonna be evaluated during function definition. If you do not pass the argument to the positional or the default argument, so it will take the default value as a default argument. So default values are evaluated when the function is defined, not when it is called. You can modify the default arguments inside the function. For example, y is 6. Take 6 instead of 4. Okay, 6. 2 plus 6 is 8. You can also pass arguments instead of the default value. So it will take the argument taken, but the default argument is defined or modified inside the function. And when you are avoiding that, it will take this one instead of default value. So this is called default argument. So you can also use default arguments in the function definition. And I hope you enjoyed this tutorial and you understand about parameters versus arguments, the number of parameters and arguments, positional arguments, and default arguments in this tutorial. Don't forget to write comments below and see you in the next episode. Thanks for watching. Hello everyone, welcome back to day 9 of Python for Beginners tutorial. And this day 9, you will learn the conditional statements and loops. After completing this lab, you'll be able to work with conditional statements such as if statements, nested if statements, if else statements, and if else statements. You'll also work with loops such as for loops, while loops. So don't forget to like, share, and subscribe, and let's get started. In this tutorial, I'm going to start from the conditional statement. The conditional statement is including comparison operators, branching, and logical operators. The branching allows you to run different statements for different inputs. It is helpful to think of an if statement. For example, the conditional statement is just if statement is if there is a condition and there is a block of statements like a function. You've already learned about functions, and the block of conditional statement is similar with the function block. So in the block of statements, you can do some block of statements or something. And based on the result of the conditional statement, it's going to return the do statements Otherwise, if this condition becomes false, it prints the else part. Let's assume there is a locked room. So the if statement has a locked room, and the result of the if statement is true based on the evaluation of the conditional statements. You can enter the room and your program will run some predefined statements in the block of a statement or body of the conditional statement. But if the statement is false, which means the room is locked and you can't enter into the room, and the else statement can run something. So that is the else parts of the conditional statements. So this is a general syntax of conditional statements. So there is if statement, there is a condition that evaluates the Boolean value, either true or false. Based on the condition here, it's going to return the statements inside the conditional statements. For example, you might want a game to print the message high score. So let's do this. We first define a function high score, and this function takes two parameters, the player score and high score. So this function going to do that, there is a conditional statement inside this function. So you can do, so now we are going to develop an application or a program that can perform something, because we are learning step by step, and now we are organizing our codes. We are started from the variable declaration, operators, expressions, and now we have seen about functions, parameters, arguments. Now we are going to do the conditional statements and loops, and we organize our code and perform some tasks. Okay, that's it. So in this example, I'm going to show you that to develop a game to print the message high score, but only if the player's score is higher than the previous high score. Here, the function takes player score and high score. Then, based on the condition we are going to define in this function, it's going to evaluate either true or false, and the program will print the high score or low score. Okay, so you can write this as a formal logical statement if player score is greater than high score, print high score. So it's just assign the player score to the high score, so that, which means in this case the player score is higher than the high score, the initial higher score. So it prints high score, and it just assigns that player score to the high score. Now the high score is the player score. And if the player score is not greater than the high score, this is based on this decision, it evaluates false. It prints that this is low score. And finally, the function returns a value, and it returns that the high score, the value of high score as a result. So this conditional statement is evaluates either true or false based on the scores of the player. So if the player score is higher than the high score, the initial high score, it prints that the player score is high score and assign the player score to the high score. So the previous high score is modified. Otherwise, which means the player score is less than the high score, it prints that the player score is low score, and finally returns the high score. Now let's call the function. Call the function, and let's assign value to that function. Score, high score. For example, the initial high score is 83, 90. Player score is 83 and high score is 98. I just pass the scores of the players to the function as an argument, and automatically assign the score, player score to the player score, and this value to the high score. So the previous high score is right now 98. So this condition evaluates to false because the player score is not greater than the high score. So it just goes to the else parts of the conditional statements, and it printed that it is low score, and finally it returns the high score. The high score, it could be 98. Okay, let's print and let's see score. Yeah, the player score is low score because this 83 is not greater than 98. So this is a condition. You are developing a game application that evaluates based on the player score and previous high scores. And we can do one more score too. High score. For example, let's pass 95 is the player score and the previous high score is 93. So right now, it's just score 2. And the second function call, I passed the player score is 95 and the high score is 93. So it just evaluates that the player score in this case is greater than the high score. So it prints high score, and the high score is now modified and assigned the player score to the high score. And finally, it returns the high score is 95 because the current player score is greater than the previous high scores of the player. So this is what's called a simple conditional statements, including branching, logical operators, and functions also. And we are organizing our codes and building one program that can solve a problem, that can make a decision either the current player is higher score or not. Okay. So with if statements, we use similar syntax as we used for organizing functions. With functions, we had a def keyword that used to define a function followed by function name. And that function may take parameters or not, list of parameters. And that's called arguments. And it also followed ending with the colon and an indented body of statements. So the conditional statements are the body of the function. And inside the body of the function, we define the conditional statements, if statements. So the if statement is similar with the function, the organizational function. So we have if keyword that used to define if statement and followed by the conditional expression. The conditional expression evaluates to Boolean value. The result of this evaluation is either true or false. Then this ended with the colon, and whatever ended with the colon, it must have the value of statements inside that code block. So for example, we have a statement that's gonna be printed based on the decision of this conditional statement. So if this is true, it prints out the statements inside the if statements. Otherwise, it goes to the else parts of the conditional statements that gonna be printed out, and the function gonna return the values of the function that is high score. So conditional statements are used to control your program flow. If you're developing more complicated program, so you can nest your if statements. You can define, for example, in the previous class, we have seen that we can define a nested function or inner function inside the function. The same is true in the conditional statements or if statements. We can define a nested statement. Let's do some example. Let's comment this and let's do some example. Variable if dot x is less than 50, and inside this if statement, we can define another if statement, that is nested if statement. If x modulus 2 is 0, it returns that branch A. So this if the nested if may have else part. If that is this if statement is false, it prints the nested else part, that is branch B. If the statement is out of this, which means this the outer if statement is false, it goes to the else part of the outer if statement, that is else, and it returns branch. All right. So now let's call the function. Okay, so the result is branch A because 40 is less than 50. So that is evaluated to true. And if the outer if statement is true, it goes to the nested if statement and it evaluates to the this part, which means 40 modulus 2 is, there is no reminder in this case, so it equals to, the remainder is equal to 0. So it returns branch A. So if, for example, the nested if statement, let's evaluate 41. It is to B because the outer is already true because 41 is still less than 50, and it goes to the nested if statement and it evaluates to the if parts of the nested if statement, and 41 modulus 2 is not equal to 0. So the remainder is greater than 0. And so if this is false, which means it goes to the else parts of the nested if statements and it prints or returns the branch B. Okay, let's, for example, 54. Let's make 54. Now it goes to the else part of the outer if statement because x is 54 and 54 is not less than 50. And this is evaluated to false, which means it goes to the else parts of the outer if statement. So in this example, we have an if statement is nested under another if statement is. And as we change the input, we end up on different branches of the if statements. So we have seen this, each of the examples. And the statement that follows the if is called the condition. And the condition can be either true or false. Based on that true or false, it executes the statements under that if statements or else parts of the conditional statements. So let me give you an assignment that you can solve and post in the comment section of these video tutorials. So the question is that you are going to solve is write a function takes in a number and returns true if it is greater than 10, but less than 20, or it is less than minus 100. So try to write a program and post the solution in the comment section of this video tutorial, or you can also post the solution in the Telegram groups, and I will evaluate and discuss further about your solutions. And now let's go on about lupus. So lupus in Python is very essential. So conditionals are very useful because they allow us, our programs, to make decisions based on some information we provide. Thus, decisions control the flow of our program. Uh, and we have one other major tools for controlling program flow, which is repetition. In programming, we will use repetitive loops to execute the same code many times. So that is called iteration. A repeated execution like loops can perform iterations. So we will look at the two types of loops, the for loop and while loops. So before we discuss about loops, let's discuss the range object. A range object is very important. So in the range, this is a built-in function that helps us to uh, print the ranges of numbers. For example, if you want to print the ranges of 10 numbers. 10 numbers means, so it starts from 0 by default, and it's just holds the numbers 0 up to 10. So the range function has a start and end number. It's always start with the starting point and end is with the end point. So in this case, ending point is 10 and the starting point by default is 0. For example, if you specify the starting point is 1, it starts from 1 up to 10. So that is what called the range. So this range is very helpful for our iteration. So the for loop enables you to execute a code block multiple times. For example, you would use this if you like to print out every element in a list, a dictionary, or a tuple. Let's try to use for loop to print out a sequence of numbers from 0 up to, for example, let's say n is 11, and we use for I in range n. Then it's gonna print the number I. So this is a simple syntax of the iteration. We use the keyword for, and I is the iterator that iterates through the range of numbers. It starts from 0 by default. The in keyword is that used to that is a member. So for I is a member of the range of numbers from 0 up to n. So we have discussed about the in operator previously. So that is a membership. And like if statements, functions, for loop also has a block of statements. So this ended with colon, and this for loop has a block of statements or a bed of statements inside the for loop that's gonna be printed out. So the for loop in this case, it just iterates over the range of numbers 0 up to 11, and it prints every number in the range. So in this case, so it starts from 0, it prints 0, it goes to 1, repeated again and again until it becomes false, which means the number is greater than 11. It iterates over and incremented by 1, which starts from 0 and goes to terminated the loop and printed out the result. So this is the for loop that, for example, if I start with 2 and int 12, and I start from start int. So it will not include the int. It's up to 12. It starts from 2 and including the starting point, but not including or excluding the end point of the range. So the range starts from 2 up to 12, and it prints out the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, not including the last number in the iteration. So that is what a for loop that is help us to print the statements many times. So that's, as you can see, the for loop is used for a control flow of repetition. However, what if we don't know when we want to stop the loop? So it is not exactly know when the loop is terminated. What if we want to keep executing a code block until a certain condition is met? So the while loop exists as a tool for repeated execution based on a condition. So there is a while loop that executed the program until some certain conditions are met. So the loop for repeated execution based on a condition, though the code block will keep being executed until the given logical condition returns a false Boolean value. For example, the most basic kind of iteration is the while loop. A while loop will keep executing so long as the condition after the while loop is true. Okay, let's try to see an example of while loop. Let's say n is 10, and let's try to see the Fibonacci series. Fibonacci, the F1, F0 is by default 0, F1 is 1, and let's print Fibonacci F0 and F1. Then we're going to just define the count starts from 2. Then while the count is less than n, this is the condition. And inside this, we determine the next Fibonacci, which is F0 plus F1. That is the next Fibonacci. So you can read about Fibonacci series and print that the next Fibonacci, and we assign that F0 and F1 to F0. So the F1 would be the next Fibonacci. Then the count going to increment by 1. So we can plus assign, so that's the operator. And so this is the Fibonacci result. So always 0 is the first Fibonacci, 1 is the, 0 starts from Fibonacci 0 and Fibonacci 1 is 1. It repeats the Fibonacci 1. Then the second Fibonacci is 2, 3, 5, 8, 13, 21, and so on. So it's continue until 41, 81. For example, if you reduce the number of, so we know that this program will execute until this condition becomes false. For example, this counter incremented by 1, it starts from 2, and when every iteration it increases by 1, and it becomes 3, 4, 5, 6, 7, 8, 9, 10. When it becomes 10, 10 less than 10 is not true, that is false, and it stops iterating the loop and stops executing the program. That's while loop is better for some cases. And for loop is also important in, it's actually, it depends on the tasks that you wanna do. So the most basic kind of iteration is a while loop, and the while loop will keep executing so long as the condition after the while loop is true. So these are today's lesson about conditional statements in loops, and I hope you learned something new. And don't forget to like, share, and subscribe to my YouTube channel. Thanks for watching today. Hello everyone, welcome to day 10 of Python for Beginners tutorial. In day 10, you will learn the essential Python built-in modules. Embark on your Python programming journey with this comprehensive guide to essential built-in modules. You will discover how to utilize the essential tools to solve wide range of programming problems, from mathematical calculations to data manipulation and web scripting. So in this tutorial, I will explore some of the essential Python built-in modules, and I will show you practical examples how to use the built-in modules in your Python program. Let's go. In this example, I will try to show you how to find the area of squares using math modules. First of all, you will need to import the module that is math. To import the built-in modules, you use the keyword import and follow it by the name of the module, math. So this math module provides mathematical functions such as sine, cosine, tangent, square roots, log. So that are some of the functions that this math module provides. So we can perform such mathematical calculations using this math module. In this example, I will try to show you the area of a circle. So first of all, you can define the pi. So the math module provides the constant pi using math.pi. And now we can calculate the area by defining the radius of the circle. Radius of the circle, for example, is 5, and let's calculate the area. Area is pi r square, or you can use pi times r times r. Then you can print out the area of the circle, which is, all right, so this is 78.5 with the radius is 5. So you can use either this to calculate, because area of the circle is pi r square. That is the formula, and the pi is the constant that the math module provides. Or let's say this is area 1. Or you can use another way, the pow function from math. So area 2 is, for example, pi I multiplied by math.pow. This pow function just uses the r argument and the 2. So because area of circle is pi r squared, so it multiplied the r itself. So in this case, we pass r and 2 to square that r, and then multiplied by the pi. That's the same. So let's print. Yeah, that's the same result with this one. So this math provides some of useful functions like pow, like pi, and we can also calculate the square root of numbers. So let's say we have a number n, for example, n, and the square root of a number is math.square root. And we pass that n to that square root, and we get that. So this can get, so the square root of 4 is 2. Yes. So this math module provided the function square root, and we pass the number as an argument to the function square root. So those are some of the examples that can perform any mathematical calculations using math module, because this provides a lot of functions. All right, the second module I want to show you in this tutorial is random. Random module is very essential, which provides functions for generating random numbers and selecting random items from a sequence. So we first import that random, and we can, for example, generate random number between 1 and 10. Random number, random dot, rand int. We specify the range of the numbers in this function, rand int. So for example, 1 up to 10. It's going to generate the numbers in between 1 and 10. So now let's print random number. So this is random number that's found in between 1 and 10. So every time it's prints random number in between 1 and 10. It just picks the number randomly. Especially this helps us to develop the game like guessing game. So you can guess random number in between some ranges. So this is one of the examples that used to generate a random number between 1 and 10. So when you run this code again, it generates 10. But it couldn't generate numbers greater than 10 or less than 1 because we are specified the ranges of the number. So that's what random can perform. All right. Let me show you one more built-in module. For example, the datetime module. Let's import datetime module, and this datetime module provides functions for working with dates and times, including creating, formatting, and parsing date and time objects. So in this example, I will show you how to get the current date and time using datetime module. So for example, current datetime is datetime dot datetime again dot now. Now is the function that obtains the current date and time. So you can print the results current date time. So the current date and time is this one. So this is one of the modules that used to obtain current time and dates using this datetime module. The other important thing here I want to show you is, for example, let's import this. And what are the functions this module provides? So to get that, here is a dir function that used to list out the functions that the module provides. For example, I pass math. Look, so the dir function is very essential. So if you don't know the functions that the module provides, you can use dir function and pass the module name into this function and print out all the classes or attributes of that module. So here, for example, there is a cos, decrease, let me show you some square roots, tangent, tan, radians. So there are a lot of functions. So you can then pick the function and you can do something that you want to perform. There are also other built-in modules such as OS module, SYS module, string, and RE module, collections, just that. Those are other essential modules, and one more module is, for example, URL library. These modules provide different functionalities to perform different tasks. For example, the OS module provides functions for interacting with the operating system, such as opening, closing files, reading and writing to files, and executing external programs and manipulating the folders, files in your operating system. So you can watch the video tutorial how to work with directories, files, and other things in your operating system. The other is SOS that provides information about the Python system, such as the current version of Python and the command line argument string. So a string is also a built-in module that provides functions for working with strings, such as finding substrings, uh, replacing characters, and converting between uppercase and lowercase uh, characters. Array is one of the most powerful module that provides functions for regular expressions matching and manipulation. And you can learn a lot about array, and you can perform different projects, especially in pattern matching. Collection is also useful for providing a variety of collection data structures, such as lists, dictionaries, sets, and queues. JSON is also useful built-in modules, which provides the functions for parsing and generating JSON data. And the other is URL library. So this module provides functions for making HTTP requests, which are used to fetch data from websites. So in conclusion, these built-in modules provide a wide range of functionalities that can be used to solve a variety of programming problems. As you learn more Python, you will find that these modules are essential for writing effective and efficient Python code. I hope you enjoyed this tutorial. Don't forget to like, share, and subscribe. Write comments below. Hello guys, welcome back to day 11 of Python for Beginners tutorial. In this day 11, we will develop a number guessing game. This project covers all the topics from day 1 to day 10, which incorporates functions, variables, strings, loops, and conditional statements. This game will able to generate a random number between 1 and 100 and asks the player to guess it. The player has up to 10 attempts to guess the correct number, and then the program will provide feedback on whether the guess is too high or too low after each attempt. The game also uses functions like display welcome, get user guess, evaluate guess, and play game to organize the code and make it more readable and modular. So let's get started. We first define a function that's just display welcome messages for the player. Okay, now this display welcome function going to display the message on the console, and the player could read that welcome to the number guessing game, and then the player can think of a number between 1 and 100. Okay, now we're going to define a function, another function that get user guess. In one Python file, we can define multiple functions, and even though we can call a function inside another function. So we will see and we will practice more and more by developing such kind of game. Okay, let's get started. This is another function that is called getUserGuess. The function going to perform while loop. The while loop just evaluates to true. If this is true, that's going to run this program. So the program just accepts the user inputs function that allow users to enter data from keyword, and user inputs going to convert or cast into integer, because the number we are going to guess is integer number between 1 and 100. So it should be casted into integer. And finally, return to that guess number. If there is error during entering data, if the user may enter inappropriate or incorrect value, so it just prints that please enter a valid number, that is value error exception handling, and that is called. So in this function, we cover the loop, while loop, try or exception handling, and casting event, type casting, or converting input type into integer type. So this is what gets user input. Then next, we are going to define another function that evaluates the user guess. All right, this function just take two parameters, target and guess. The target is the number which is randomly generated between 1 and 100. And the guess is the user input that the user guesses. If that the user guess is less than the target or the randomly chosen number, it returns too low. So the user can aware of that number is too low, and then the user going to attempt another guess, which is greater than the first attempt. And there is a elif statement. So the elif going to evaluate that if guess is greater than the target, just returns the message to high. So still the user can be aware of that the user input is still high, and the user can reduce the another attempt. Then if the user guess and the target is equal, which is the else part, that is the correct guess, and it returns congratulations, you guessed the correct number. So this is what that evaluates the user guess. All right, now we are going to define another function, which is play game. The play game function going to call the function is display welcome, that displays the welcome message, get user guess, that allow users to input the guess, and going to call the function evaluate guess, and that evaluates the user's attempt. Okay, let's define that function and let's do that. So this play game function going to do that, because in this function we define a random number generation, which is using random module. So we need to import this module in the beginning of this program, import random. And this going to randomly choose the number in between 1 and 100, and just stored in a variable target number. And there is attempts that counts the number of attempts that the player try. And if the player reaches to the maximum attempts, it's going to terminate the games. And this display welcome function is called here, and display the welcome messages in the beginning of the game. All right, let's go. Okay, then there is a while loop that evaluates the condition. If the attempt is less than maximum attempts here, the minimum attempt is, or initial attempt is 0 and maximum is this. And this attempt is going to increment by 1. And if that attempt is less than maximum attempts, allow the user to input another guess, which calls the function get user guess. The user guess just allow the user to input another number, and then call the function evaluate guess, and the evaluate guess takes two arguments, the target number, which is auto generated, which is randomly chosen from between 1 and 100, and pass the user guess to this function as an argument, and it's going to evaluate the statements inside this function. So this is going to be evaluated when this function is called inside the play game function. So this concept is what is called, we are calling functions inside another function. That is called function call. All right, let's continue. All right, I added another lines of code here. If the user guess is equal to the target number, which is the user guessed the number, and it just prints that the attempts that the user took, and it prints the congratulations message as well. And it increments the attempts by 1. And there is a break statement here that breaks if the user guess is correct. It just breaks the statement and goes to, or the loop stops here. It will not evaluate again because the user is correctly attempted that guess. Otherwise, it continues increment the attempts. If that attempt is equal to the maximum attempts, which is 10, it reaches to 10, it prints out sorry message. Sorry, you ran out of attempts. The correct number was prints the correct number, the target number, which is randomly chosen here. So now we have finished our code, and we are going to call the function play game outside of the function. And we can use a name that uses as entry point of the program execution. Name, call that play game, because other functions are called inside the play game, and everything can be done here. Then when you call that fly game outside of functions, and when you run your program, it starts from the main function, and the main function calls the function fly game, and the fly game generates random number and calls the display welcome function and evaluates the attempts and so on. All right, now we are going to run our code and let's play the game. Okay, there is an error, which is attributes error random has no attributes random int. So I should correct that error. So here it's not random int, but it is rand int. And let's run again. All right, this is the output, and the welcome message is displayed here. Then you can enter your guess first attempt, for example, 56. Okay, the guess is too low, so it just evaluates your guess and it outputs your guess is too low, so you have to guess another attempt which is greater than the previous attempt. For example, 78. Oh, it is high. Now we can attempt another guess. For example, 68. Still it is high, and I can 62. Okay, 59. Okay, 57. Congratulations. I just correctly guessed the number, and it took me 6 attempts to guess that target number, 57. So this is what the game we have developed in this tutorial. You can practice more and more, and you can be a perfect Python developer, and you can solve different problems. I hope this tutorial covered all the topics you have learned from day 1 to day 10. Don't forget to like, share, and subscribe. Write comments below. Thanks for watching.